Right, this is another past exam question. So this is from Edexcel. It's a further maths question from FP3 June 2012, and this was question number 3 of that paper. So let's have a read. The position vectors of the points capital A, capital B and capital C relative to an origin O are I minus 2j minus 2k, 7i minus 3k and 4i plus 4j respectively. Find, and in part A we need to find the vector or the cross product of AC and BC. So let me do that part over here. So let me collect the data. So we have these vectors. So we have OA. So OA is given by I minus 2j minus 2k. So let me copy that down. So I minus 2j minus 2k. And we also have OB. So let me write that down over here. So OB, and OB in this case is 7i minus 3k. So that is 7i minus 3k. And we also have OC, and OC according to the question is defined by 4i plus 4j. So 4i plus 4j. Now let's calculate the vectors AC and BC first. So for AC, so to work out AC, AC would be OC minus OA. So let me continue. So AC is equal to, now OC, that's defined as 4i plus 4j. So 4i plus 4j minus, and OA, that is defined as I minus 2j minus 2k. So I minus 2j minus 2k. Now if I add the like components, so firstly the I components, 4i minus I, so that would be 3i. Let's add the j components, so be careful. 4j minus of minus 2j, that would be plus 6j. And finally the k components, minus into minus 2k, so that would be a plus 2k. So that is the vector for AC, but let's also calculate the vector BC. So let me scroll down a little. So in the same way, BC, so to work out BC, BC would be OC minus OB. So let me continue down here. So BC, that is equal to, now OC is defined as 4i plus 4j. So 4i plus 4j minus, and OB rather, so OB is defined as 7i minus 3k. So 7i minus 3k. Now let's add the like components. Firstly the I components, 4i minus 7i, that is minus 3i. Let's do the same with the j components. So I only have one j component, which is plus 4j. So plus 4j. As for the k components, I only have one k component. So minus into minus 3k is plus 3k. So this is the vector BC. Now if we go back to the question, we need the vector or the cross product of AC and BC. So let me show you how that is done. Now prior to doing that, if you're unaware in terms of how these calculations are done, I have created videos on vectors and I'll provide links to those videos in the description below. So be sure to check out those videos. So let's concentrate on the vector product of AC and BC, and also if you're unaware of how to conduct the vector product or the cross product, I'll provide links to those videos also in the description below. So let me talk briefly or in terms of how we work out the cross product though. So we need AC cross BC. So let me amend that. So BC. So what I normally do is, to work out the vector or the cross product, we calculate the determinant of a 3x3 matrix where the first row are the unit vectors I, J and K. So we write the unit vectors I, J and K always for elements along the first row of this determinant. The second row are the coefficients of I, J and K in the vector AC. So the coefficients of I is 3. So I'll write down 3 here. Coefficient of J in the vector AC is +6. So it's a +6. Coefficient of K in the vector AC is +2. So just to repeat, in the second row, coefficients of I, J and K in the vector AC as AC appears first. And in the third row of this determinant, you would write down the coefficients of I, J and K in the vector BC. So the coefficients are -3, so we write down -3 here, +4, so we write down +4 here, and +3. So determinant signified by this symbol here mathematically. Now to evaluate this determinant, so what I normally do is I write the signs associated with the first row. So the signs associated with the first row are plus, minus and plus, and then I expand using the first row. Okay, so using the first row, if I expand and take into consideration the signs associated, so we have a plus I, so it's a plus I multiplied by the determinant of a 2x2 matrix, and the elements of this determinant can be found by ignoring the row and the column associated with I. So if I ignore the row and the column associated with I, we're going to have these elements 6, 2, 4, 3. Close the determinant sign. Let's continue. So minus the J, so minus the J multiplied by the determinant of a 2x2 matrix again, where the elements can be found by ignoring the row and the column associated with J. So if I ignore the row and the column associated with J, we have the elements 3, 2, so 3, 2, minus 3, 3. So minus 3, 3, close determinant, plus a K, so plus a K, multiplied by, again the determinant of a 2x2 matrix, where the elements can be found by ignoring the row and the column associated with K. So if I ignore the row and column associated with K, we see the elements 3, 6, so 3, 6, minus 3, 4. So minus 3, 4. Close determinant. Now, let's continue. Let's expand these 2x2 determinants. So we have a plus I multiplied by. Now, to evaluate a 2x2 determinant, what you need to do is, if I take my red pen, first we multiply the elements along this diagonal. So we call that the leading diagonal. So if I multiply the elements along the leading diagonal, 6 times 3 is 18. And then we subtract, so we always subtract. And if I take a green pen, then we multiply the elements along the lateral diagonal. So lateral diagonal is my green diagonal. And if I multiply the elements along the green lateral diagonal, 2 times 4 is 8. So let me just repeat that step. So to evaluate a 2x2 determinant, first multiply the elements along the red leading diagonal. So 6 times 3 gives me the 18. Always minus. Then multiply the elements along the lateral green diagonal. 2 into 4 gives us this 8. Let's continue. So minus j, open a bracket. So remember the procedure. First multiply the elements along the leading diagonal that I've highlighted in red. So if I go back to my favourite colour blue, 3 into 3 is 9, always minus. And if I take my green pen, then multiply the elements along the lateral diagonal, this diagonal over here. 2 times minus 3 is minus 6. Minus 6 into this minus makes it a plus 6. Okay, plus a k, so plus a k. Let's do the same for this 2 by 2 determinant. So red pen, first multiply the elements along the leading diagonal. So 3 into 4, that is 12. So it's a 12, always minus. And if I go back to my green pen, then multiply the elements along the lateral diagonal. So the lateral diagonal, I've shown that in green again. 6 into minus 3 is minus 18. Don't forget this minus, making it a plus 18. Now, let's tidy this up. 18 minus 8 is 10, times I is 10i. 9 plus 6, so 9 plus 6 is 15, multiplied by minus j, minus 15j. And 12 plus 18, so that is 30, times k, so plus 30k. So this should be the solution for the vector product or the cross product for AC cross BC. So that is the conclusion for part A. So we've done part A. Now let's have a look at part B. So part B, let me do part B over here. Part B is to calculate the area of the triangle ABC. Now, if you're not aware in terms of how to work out the area of the triangle, let me write down the formula. So to work out the area of a triangle, so using vectors, the formula is half modulus, and regards to the problem, it's half the modulus of the cross product of AC cross BC. So that is the formula that we need to apply in order to work out the area of the triangle. So as you can observe, we have AC cross BC. So from the previous part, AC, so let me copy that down, cross BC, and as a vector we had, so let's remind ourselves, 10i minus 15j plus 30k. So 10i minus 15j plus 30k. So that is AC cross BC. Okay, so that is from part A. So let's just say C part A. So that comes from part A. So however, we need the modulus of this vector. So modulus means the size. So in this case, we need the modulus of AC. Whoops, so let me make it as neat as I can. Cross BC. And to calculate the modulus, we need the square root. So it's a square root of the coefficient of I, which is 10 squared, plus the coefficient of j, which is minus 15 squared, plus the coefficient of k, which is 30 squared. So if you're unaware in terms of how to work out the modulus, I have created a video in the past on the principle, and I'll provide a link to that video in the description below. So however, let's continue. 10 squared is 100, plus 15 squared, that is 225, plus 30 squared, that is 900, Now, if I key that into the calculator, so let's key that in. So we have the root of 100 plus 225 plus 900. And if we work that out, we should have a nice answer of 35. So let me continue over here. So we have 35. So that it being the modulus of AC cross BC. But let's apply this to our formula. And let's work out the area of the triangle ABC. So in this case, so therefore, so for the area of the triangle A, B and C, so remember the formula, it's half the modulus of AC cross BC, and if we apply the result that we had in the earlier calculation, modulus of AC cross BC, we had 35. So I'm going to leave it as 35 over 2. So that's going to be the solution for the area of the triangle ABC. So that completes part B. Now let's have a look at part C. Find an equation of the plane ABC in the form of r dot n equals p. So let me show you how to do that. So let me do the last part C over here. So in this case, in order to work out the equation of the plane, so they've given you the formula. So this is the formula for the plane in scalar product form. So the equation of the plane, so that formula being r dot n, and that is equal to p. Okay, and as I said earlier, this is the scalar product equation for the plane. So this equation is in what we call scalar product form. And let me briefly explain the notation in this formula. Now, I have created videos in terms of how to work out the equation of the plane, explaining the principles and the method also. So I'll provide links to those videos in the description below. But let me give you the brief points when it comes to this formula. So R is the position vector of any point on the plane. N is a normal vector of the plane. Normal means a vector which is perpendicular to the plane. Whereas P, to work out P is going to be calculated by working out A, which is the position vector of a fixed point on the plane, dotted with N, and N again is the normal vector of the plane. Okay, so that is how you would work out this scalar P on the right hand side. So let me quickly take my red pen just to show you how we're going to calculate P, this scalar. Now going back to blue, now we're working out, just as a reminder, the equation of the plane containing these 3 points A, B and C. Now for N as I said is the normal vector of the plane, or vector perpendicular to the plane. And by calculating AB cross AC, the result of AB cross AC, which is this vector here, this is the vector which is going to be perpendicular to our plane A, B and C. So by working out the cross product of AC and BC, this will give us a vector which is perpendicular to our plane ABC. So N is AC cross BC. And let me copy down the results that we had from part A. We had 10i minus 15j plus 30k. So that is AC cross BC, which is the normal vector for this plane. Now for A, with regards to A is a fixed point on this plane. Now we have 3 fixed points. A, B and C are all fixed points, all contained on this plane A, B and C. So in that case, I'm going to take A, in this case, to be OA, since OA is a fixed point on our plane, but you could also take it to be OB or OC as well. So with regards to my calculation, I'm going to take it to be OA, and let me copy that down, I minus 2j minus 2k. So I minus 2j minus 2k. But just to repeat, you could also take it to be OB or OC, as all of these 3 points are points contained on our plane. All of these points are fixed points. And the distinction between a fixed point and R is the position vector of any point on the plane. Okay? So once again, I have explained these principles clearly in a video that I did in the past, and I'll give a link to this video on planes in the description below. However, this is the data that we need to work with, and going back to P, let's work out P by working out the scalar product of A and N. So let me continue here. So P is A in this case is I minus 2j minus 2k, dotted with, so we're taking the scalar product of that with N, which is 10i minus 15j plus 30k. So let's continue. So to work out the scalar product, and once again I've created a video on the scalar product also, I'll provide a link to that video in the description below, but let me briefly talk to you about the principles behind the scalar product. So a quick way of doing this is to multiply the coefficients of I, then we add, then multiply the coefficients of j, then we add, then multiply the coefficients of k. So if I multiply the coefficients of I have 1 times 10, so 1 into 10, and then we always add, then multiply the coefficients of j, minus 2 from here, multiplied by minus 15 from here, always add, then multiply the coefficients of k, minus 2 from here, multiplied by plus 30 from here. So if I continue, let's remove the brackets. 10 into 1 is 10. Minus 2 into minus 15 is plus 30. And minus 2 into 30, minus 60. So if I continue along the line, 10 plus 30 is 40. Minus 60 is minus 20. So that is going to be the solution for this scalar P. And we have the information needed to work out the equation of the plane in this form. So let's substitute. So in this case, our equation of the plane, so therefore equation of the plane A, B, C. So it's R dot, so it's going to be R dot. N, the normal vector, we had 10i minus 15j plus 30k. So 10i minus 15j plus 30k. And that is equal to P, and P, the solution is minus 20 from a prior calculation. So that, I believe, would be the solution to this particular part C. So that completes the part, and that also completes the entire question, and that sadly ends this video. So I hope you found this video helpful. If you did enjoy the video, be sure to like and subscribe for more content like this, and I hope to see you again. Thank you.